right, today we are learning our final type of factoring, which is the grouping method. So far we have done GCF, we've done double bubble, we've done difference of two squares, and now the final one is the grouping method. When you do grouping method, usually, okay, and this is a big usually, it's 4 terms or more. Grouping method can be done with 3 terms. It's just we're not doing it in this class. So we are focusing on 4 terms in this class. So when you see a problem with 4 terms, automatically in this class, you're going to think grouping method. First thing I would check is there a GCF though for all 4 terms? You always want to do that. Make sure that you can't simplify this before you begin. So if you look at all 4 terms, I'm looking at the coefficients 1, 3, invisible 1, 3. There is no common factor there. And then I also look at the variables, and they all don't have the same variable. This guy at the end doesn't have a p, so I can't do any GCF in this question. So what we're going to do for grouping method is we're going to group together, which is why it's called grouping method, the first 2 terms and the last 2 terms. I'm going to group together the first 2 terms and the last 2 terms, and I'm going to find a GCF of these 2 terms only. So if I look at just these 2 first terms, p to the 5th plus 3 p to the 3rd, there's a GCF of p to the 3rd. If I take out the p to the 3rd, I'm left with p squared plus 3. I'm then going to look at my last 2 terms and look for a GCF. We're starting off with actually kind of a tricky question here, but I wanted to do it right off the bat. There is no GCF, but for grouping method, you have to take out a GCF. Like that's the only way this will work. So because there is no GCF, we're going to take out a 1. This is not something we normally do, but we're going to take out a 1. And I'm going to put a plus sign here to show that it's positive. So I'm dividing everything by a GCF of 1, which doesn't change my binomial. So this is now my next step. So now what I'm going to do is what's happened here is I've narrowed my 4 terms, right? There was 4 terms on this step. I'm now down to 2 terms. Okay? This box right here is considered all the first term because we separate once we see this little plus sign there. So this is my first term, and then this is my second term, right? Those are my 2 terms. I'm going to ask myself, of these 2 terms, what's the GCF? What do these 2 terms have in common? And if you have colored pencils, you can do what I'm doing and color coordinate here, right? What do these 2 terms have in common? They both have a GCF of p squared plus 3. They both have this bubble. So I'm going to take that GCF out. When we take out a GCF, we always put it down in front, right? Our GCF up here was p to the 3rd. We put it down in front. Our GCF here was 1. We put it down in front. So the GCF for this question, we're going to put it down in front. And then after we put the GCF in front, we make a bubble of what would be left over. So if I divided this first box by p squared plus 3, because that was my GCF, what happens is those cancel because they're the same, and all I'm left with is p to the 3rd. If I divide this second box, this pink box, by my GCF, those cancel because they're the same, and all I'm left with is the plus 1, right? So to recap what happened, back at the first step up here, I took out a GCF, got this new pink box, took out a GCF, got this pink box. Both pink boxes had this in common, p squared plus 3, and then my second bubble is the other stuff that was remaining. So p to the 3rd and 1. That became a second bubble. Now, once you get to this point, you are looking at these two bubbles, asking yourself, can I go any further? Is there more factoring that can be done? So things you would want to think about is, can I do a double bubble with anything? Can I do difference of two squares? Both of these are binomials, but they're addition. So difference of two squares is out. So this now is my final answer. And FYI, this bubble here can be factored further. It's called a sum of two cubes. You'll learn this in Algebra 2. So I'm not expecting you guys to take that any further, but just a heads up. All right, let's try another example. Number 2. So what I'm going to do, I'll try to stick with the same colors here. I'm going to group together the first two terms and find a GCF. Side note, before we begin that, let's look at this whole thing. Is there a GCF for the whole 4 terms? No, there is not, right? Always check for that first. Now, is it always grouping the first two terms together? In this class, for this level of difficulty that we're doing, yes. You will always group together the first two terms and the last two terms. When we get to the challenge questions, that could change. You might have to rearrange, but that's just for challenge questions. So the GCF of these first two terms is x squared. If I divide each of these things by x squared, I would get 2x plus 3. I'm going to do a GCF over here. So I can't do a variable GCF because the 9 doesn't have a variable. So I'm looking at the 6 and the 9. What are 6 and 9? The biggest number they're both divisible by is 3. So I'm going to take out a positive 3 GCF. If I divide each of these things by 3, I would get 2x plus 3. Right? Now is where I would go and look at my two pink boxes. So this is all a box. This is all a box. You don't need to draw these, right? But some people in their head, it really helps. What do these two boxes have in common? They both have a GCF of 2x plus 3. Right? If those two bubbles are not identical, let's say one of them is 2x plus 3 and the other one is 2x minus 3, or maybe the first one is 2x plus 3 and the second one is 6x plus 7, like something totally different. If they're not identical, you can't do grouping method. Okay? If the two bubbles in each of these boxes are not identical, you cannot do grouping method. That usually means in this class that you've done something wrong, because grouping method it's going to work. I'm not going to give you something where it's prime. So something's going wrong in this class if it's not working for you. Okay. Another common mistake is people put this as squared because they think they have two of them, but that's not what's happening. We are taking out a GCF. So that's different. So that's my first bubble. The second bubble is then the other remaining terms. So x squared and plus 3. Can either of these things be factored further? No. So this is my final answer. Okay, number 3. Number 3, if you want to pause the video and go ahead and try it, go ahead and do that, and then unpause to check your answer. So in the first two terms, we have a GCF of x squared. On the second two terms, we have a GCF of negative 16. And you should take out a negative 16 because if you take out a positive 16, I'm just going to put it underneath what would have happened, you would have gotten this. And that's a problem because look, our two bubbles are not identical. So that's a problem. So that's how you know, oh man, that's how you know to take out a negative 16. Because otherwise your bubbles aren't identical. Here's my first box, second box. They have a common bubble of 2x minus 5. The leftover stuff is x squared minus 16. If you had paused this video and tried on your own, I hope that you realize that this x squared minus 16 can go further. It's a difference of 2 squares. So x plus 4 and x minus 4. As always, as long as you have the same 3 bubbles, it doesn't matter what order those 3 bubbles are in, as long as you have the same 3. All right, number 4. This one has a GCF. So if you look at all 4 terms, there's a GCF there. They're all divisible by 4. So GCF is 4. I'm going to put that out in front. Divide each term by 4. Okay, I'm going to ignore that 4 out in front. It's just going to keep coming down into my answer. And then I'm going to do my grouping method. If at any point you want to pause the video and try it, go ahead. So here my GCF is 2x squared. Over here, my GCF is negative 5. My bubbles are identical. Right, I'm going to put a bracket here just to separate that 4 so I don't by accident think this is like a 42. Right? So now I've got my 2 pink boxes. Those 2 pink boxes have an x plus 8 in common. So the x plus 8 comes out in front. The leftover stuff would be 2x squared minus 5. Bring down my 4. This, nothing can go further, right? The 2x squared minus 5 is not a difference of 2 squares because I don't have all perfect squares. So that's my final answer. All right, I'm now going to show you 2 challenge questions. So the first challenge question, it's really not that challenging in terms of like the procedure is the same. It's just that it's weird because it's a lot of variables. That's all. So there is no GCF of all 4 terms, right? 12, 4, 15, and 5 are not all divisible by the same thing. Also, they don't all have the same variable, right? Not every term has a B or a D or an X or a C. So I'm going to group together the first 2, right? My GCF there is 4B. If I divide each thing by 4B, 12 divided by 4 is 3. The B's would cancel. And the C is still there. Negative 4 divided by 4 is negative 1. I'm not going to put the 1, I'll make it invisible. The B's cancel, and I still have a D. The GCF for the second 2 terms is negative 5x. Again, at any point, if you want to pause and work ahead of me, feel free. That would get you 3c minus d. This is my first pink box. This is my second pink box. The 2 pink boxes have in common a bubble of 3c minus d. The leftover stuff is the 4b minus 5x. Final answer. So procedure is exactly the same. It's just a little weird because it's a lot of variables. That's all. And then number 6. This one's a challenge because the order of the 4 terms. So don't copy anything just yet. You can copy down the problem, but then just watch. If I put these first 2 terms together, my GCF is a squared. And that would leave me with 5x minus 4c. Then when I go to these 2 guys, I have a GCF of 3y. So that would get me 5x minus 4c. You know what? I think I made a mistake. The order is fine. Okay, never mind, scratch what I said. For some reason, I thought this problem, you would have to change the order of the 4 terms to make these 2 bubbles identical. So maybe that was a different question I was thinking of. Sorry about that. So now we're going to continue. I'm going to take out a common bubble of this. The leftover stuff is that. I cannot do any factoring any further. So this is my final answer. All right, so some of these, though, I was looking for a challenge question where this order doesn't work. Like if you group together the first two terms and the last two terms, that you don't get the same two bubbles. That was the example I thought this was. So sorry about that. When you see a challenge question, that might happen on the homework assignment that I'm posting. So if that does happen, just know that you can play around with the order. So maybe switch this term and this term, right? And see what can happen. I think it's going to happen on the homework, but I could be wrong. Okay. If you have any questions, let me know, and see you guys later.